Hey students, this is lesson 8.7, factoring special cases. We're going to learn how to factor perfect square trinomials and the difference of two squares. It says circle the operators in each trinomial. Operators are just like symbols, like subtraction, multiplication, things like that. So these are operators. That's an operator too. It tells you to multiply x by itself. Those are operators. Oh, not the 9, but the plus. There's actually another operator in there, times. And there's a whole bunch in there. So, all right, write an algebraic expression for each sum. You can pause and check back if you want. All right, here's a key concept. You've seen these already. These are some shortcuts we use for multiplying binomials together. Some special cases where we have a binomial squared, we end up with a perfect square trinomial, or either with plus or minus in it. And so if we have something like this, so this is a number squared, this is a number squared, and this middle number is twice what we have here and here. So then this would just be 4 minus 2 squared. Here we have 5 squared and 3 squared, so we'll put a 3 there, and then this number should be this times 2. All right, so we're going to use these ideas to factor these. So we have x squared minus 4x plus 4. If it's a perfect square trinomial, then this number needs to be a square number, which it is. This number needs to be a square number, which it is. And then this middle number needs to be twice the square of this times the square of this. So we're hoping that it fits one of these forms here. And since there's a minus, we're going to look at this form. If it fits this form, then we can factor it this way. Okay, and since 4, so if it works here, this a is the square root of that number. So, or the number multiplied, if we multiply this number by itself, we should get this number up here. So that means we would have an x here. And then looking at this, that's 2 squared. So we're going to put a 2 there. And then since we have a minus here, we'll need a minus here and squared. We just want to check that to make sure it works. If it does, the middle term should be minus 2 times a times b. A times b is negative 2x times 2 is negative 4x. And that works there. So, so we can factor these pretty quickly if we recognize that they're perfect square trinomial. Go ahead, try that there on this one. All right, suppose the area of a square can be represented by the expression 9x squared plus 24x plus 16. What are the expressions for each side? So here we have a square, and the area is 9x squared plus 24x plus 16. And we want the dimensions. Now, generally speaking, the area of the square is the side multiplied by itself. So we need something multiplied by itself that equals 9x squared plus 24x plus 16. Well, this first term, the only way we're going to get that is if there's some number multiplied by itself that equals that, and that can be written as 3x squared. 16 is also perfect square, so we can write that as 4x squared. So if this is going to work, this would have to be 3x, and this would have to be 4. And then our middle term would have to turn out to be 24. So, and we get that by multiplying this times this, which is 12x, and then doubling that. And that's 24x, and so that works. Go ahead, you can try that. I'll help you with the plan here first. You know the area. In this case, you're building a square patio, and you know it's a square. What you need to find is the length of one side. And length and width are both the same since it's a square. So our plan is using the area, we're going to find some side multiplied by itself, side times side, or side squared to get that. So go ahead and think about that. Try finding the right answer, and you can check back. All right, here's another concept, and you've learned this already, but for all real numbers a and b, a squared minus b squared is equal to the quantity a plus b times quantity a minus b. Notice that this will be a squared number and this will be a square number. So if you recognize that form, you can immediately know you're going to factor it like this. So think about this one here. We have x squared, and if 64 is a perfect square, which it is, it's 8 squared, then we can write it like that, and that is equal to x minus 8 times quantity x. And that's all there is to it if you recognize that form. So go ahead and try it. All right, so again, look closely. If it's a binomial and a difference, and this number is a perfect square and this number is a perfect square, and you'll know it if you can think of some number multiplied by itself that equals each of those, which we can here, then we can factor it using this idea that a squared minus b squared is equal to a minus b times quantity a plus b. So in this case, our a is 3x, our b is 5. So we can do 3x minus 5 times quantity 3x plus 5. All right, see if you can do that. All right, one more thing here we're going to learn. Sometimes it's good to factor out a common factor first, because then you might recognize one of these forms. So in this problem, look closely at the two terms here. Do they have a common factor other than 1? And they do. Notice 3 goes into both of them. So let's start by factoring out a 3. If I factor 3 out of 12x squared, I'm left with 4x squared. And if I factor 3 out of 3, 3 divided by 3 is 1. So I get that. And now this is a binomial. It's a difference. And both of those are squared because 4x squared is the same as the quantity 2x squared. And 1 is the same as 1 squared. So that can be factored using the difference of squares, which tells me that I can just split it up like this, where 1 is plus 1 and the other is minus 1. And that's the answer. Go ahead and try that here. First factor out the greatest common factor of the two terms, and then see if you can't factor the rest of it using the difference of squares idea. All right, so lesson check. Identify the rule you would use to factor this. Identify a, b, and 2ab in the expression. A is equal to 9r. B is equal to 5. And 2ab is equal to 90r. All right. We would rewrite the expression using the a, the b, and the 2ab that we just found. So we would do 9r squared minus 90r plus 5 squared. And the rule we would use, since it has a minus in, is that one. All right, that's it. I'll see you tomorrow.